All right, so we're back for the next part, and if we look at the reference here, what we're going to focus on is setting up columns, system families for part 3. Then we're going to do setting up columns for direct shape, and I'll explain the difference as I'm working through it. But basically, I'm going to start maybe backwards this time and show you guys the add column component so you can see what we need to work towards. If I come into build, I think it's in build, let's see, build, add column, it needs a curve, right? So what we have to do is create curves that are going to be our series of curves that indicate where we want our columns to be. And this is where like construction geometry and logic and things like that start to become important. So I'm going to do different curves or different column systems for, you know, if I look at my model for a second here, I can't just do, I'm going to have a set of columns that are my ground floor because I want that cantilever to be there. So I want to make sure I have my columns that come up to the underside of here. Then I'm going to have ones that go in between here and in between here, but I don't want ones on the top that go up. So really I need to make sure I'm just using this to create some columns, then this, and then this, and those are going to be treated differently because, you know, we need ones at the edge here that we don't want to run all the way down to the ground. So we kind of have to think about this as a few different systems, and then I'm going to treat the tower differently as well. And this is where we start to come back to here. And so let's start with the entry one. I'm actually going to take this and pull it over here so I can kind of work and not be going back and pulling all these wires across. And what I'm going to do is I'm actually going to offset this in. Oh, I keep getting, what is this? This is a pufferfish. Pufferfish is a great plugin for like advanced geometry manipulation, and it also has some components that just do better than native Rhino things. Like they have some really good subdivision and things like that. But I'm going to try to stick to native Rhino stuff as much as I can. We're going to use Lunchbox a little bit later, which is a great one to have, but I'll show you that when we get there. Okay, so I lost my train of thought. Entry floor curve. Offset. I want to use the, I keep doing the wrong one. I want to use the native Revit one. Offset curve, there it is, cool. All right, so then I grab that. My dimension, I'm actually going to do it in, so I'm going to do this negative. And I'll set myself up a slider that is, let's say 3, 6. I think we're probably only going to go in like 2 feet or something. Yeah, so let's go like 2 feet in. All right. So I'm just going to do columns around the edge for now to kind of give you guys a quick overview of how this works. There are more involved ways of doing interior ones. We'd also have to kind of get the core laid out to figure out exactly where the columns should fall. But again, we're just, you know, this is just to kind of show different strategies. So I'm just going to do a row of columns around the outside. But, you know, keeping this nice and straightforward, now that I have this, what I probably want to do is make sure I have columns that are spaced equally with like a target spacing around the outside. So I'm actually going to explode this curve. And I'm going to get 4 line segments. And then all I'm going to do is do a divide curve. The number is I'm actually going to take the length of each one of those curves, divide it by a target length, which, you know, for now, let's say is anywhere between 10 and 20. So let's say 10, 15, 20. Plug those in, and then I plug that in. So now I have a series of points which are, stopping at the corners and are evenly divided throughout. And again, it'll hit, whatever is the closest by rounding. So you'll see it'll jump on other sides, but it'll be as close to the target as possible while still maintaining an even spacing. And then the next thing that I'm going to do is I'm going to do a line SDL, which is start direction length. So the start is there, the direction is Z, which by default that's what it has, and the length is going to be the height for how high I want it to go. So I'm going to set this slider to be 20. So I'll get my curves that go up. So those are my columns. Now the problem right now is they're poking through that. This slab is 8 inches. We could just subtract 8 inches from this, but if we wanted to do it a little bit more parametrically, I can actually use what's called an element param. And I'm going to plug my elements in here. It's going to ask me for which parameter either to modify, or it can also just report that out. I actually want to use a I think I want to use a parameter. I can right click on here. I want to go into model categories, floors. I should be able to get the thickness. Maybe it's not thickness. Let me see here. Core thickness. Still not giving me what I want, so let me see here. Floors. Let me pause this, figure this out, and I'll be right back. All right, I'm back, and I figured this out. I knew there was a way to do it. So sometimes it can be difficult to find specific parameters using that parameter dropdown, which was this one that I was using before. So within parameter, there's this built-in parameters, which is just a massive list of all different kinds of parameters that are within the whole entire, it's every parameter in the file, so there's over 3,000. You can click up here and search, and I eventually found floor attribute thickness parameter. And so if I plug that into here, I get the thickness of them. So what this allows me to do is I can just I can flatten this. This is kind of a roundabout way to show you how to pull parameter information or parameter data. But then I'm just going to grab this, and I want to actually just subtract that from 20 so that my column stops short of the slab and not actually runs into the slab. That's just a little, so now that curve stops just short of there. So again, little bit of just kind of a convoluted way, but if you adjust the floor slab now, that column will adjust. So we're building in more intelligence into our definition. So now what I'm going to do is I'm going to add the column. And we pulled that out before, didn't we? Build column, here it is. So remember, this is in build, add column. So it's going to ask me for the curve. It's going to think for a second, and it actually gives me. It's yellow because they're identical instances in the same place. This is a thing that I encountered as I was doing this before to show you guys. But what's happening is this, when I'm dividing my curves, I have items on top of each other. So all I have to do is just split this list and remove the first item from each list. I'm going to do it at item number 1. So now I have basically the first item and then every other item. Plug that in there, and now we don't have that problem. We have a nice clean component, and you'll notice it's giving me these really nice steel sections here. As we learned before, I can change the type of that by coming into type. I can right click on here. I can go to columns, and I'm just going to do like an 18. You know what? Because it's the base, let's do a large 24 by 24. Plug that in, and now I have my big base columns down there. So we're going to recreate sort of the same logic for the podium floors. So I could take this. I'm going to actually just grab these, slide it over. I think I can cut and paste pretty much all of this. Let's see, cut and paste that. I just want to change this into here. Let's see if that works. Yep, and it works. And you know, if it's too close to the facade, we can change the offset. So you know what I'm going to do, just unify these so that they're pulling from the same place so I don't have two different sliders. But this will adjust the setback from here, and you can see it in Rhino updating as I do that. And then if I close this out, you'll actually see it in here, all my Revit columns. Okay, so that's it for the system families. I'm going to show you next how to do a different type of geometry creation using Rhino.Inside.